Unit 6, Lesson 2, Applying the Pythagorean Theorem. So in this lesson, we're going to use what we learned in Lesson 1, and we're going to use the Pythagorean Theorem to solve different types of problems, including those that are multi-step. Is it a right triangle? So the first thing to know is that Pythagorean theorem can be used to find missing side lengths, which is what we did in Lesson 1. We found the missing leg or the missing hypotenuse. But Pythagorean theorem can also be used to determine if a triangle is a right triangle or if it's going to be an acute or an obtuse triangle. Let's take a look at these first three examples on your notes. It says a right triangle can be proven with the Pythagorean theorem. So when you plug in the numbers, a squared plus b squared should equal c squared. So here's our first example. Now in all of these examples, it seems like there should be a right angle, but we're not sure because it doesn't have the square in the corner. So if the square is not in the corner, okay, if the square is not in the corner, then you can assume that it's a right angle because it could be like 89.5 degrees or 90.5 degrees and really close, which would look like a right angle, but it's not. So when you're given three numbers, you can always plug them in to see if it works or not. In this case, we know that the two smaller numbers are the legs, and the longest number is always what you plug in for C. So I like to go ahead and label A, B, and C, and then plug them in. So 6 squared plus 8 squared equals 10 squared. And I just plug them into our a squared plus b squared equals c squared. So this gives us 36 plus 64 equals 100. And 36 plus 64 is 100. And 100 equals 100. So yes, this is a right triangle. All right, make sure you're copying notes. So this is the proof. All right, in this next example, we see that the longest side is 7, so that'll be C, which means the legs are 6 and 5. So this time we're going to do 6 squared plus 5 squared equals 7 squared. And so we get 36 plus 25 equals 49, and 36 plus 25, make sure you have your calculator handy, is 61. And does 61 equal 49? No, it doesn't, but 61 is greater than 49. And it tells us up here that if the sum of the legs squared is greater than the hypotenuse squared, then this will be an acute triangle. All right, so this is proof that this is an acute. And this was proof that it was a right triangle. All right, last one. This time, our longest side will be 9. All right, so that will be our C. I always find your longest side first, and then you know the other two numbers are going to be your legs. So 6 squared plus 4 squared equals 9 squared. So this gives us 36 plus 16 equals 81. And 36 plus 16 is 52. Equals 81. That is not true. They are not equal. And 52 is less than 81. So this time, where here it was greater than, this time the hypotenuse squared is larger than the legs, the sum of the legs squared and added. Okay? So in this case, it's going to be an obtuse triangle. All right, so that's how you tell the difference. Here's an example of each type. If you get the two numbers and they are equal, then that means it is a right triangle. If you get the two numbers and the legs, the sum of the legs squared is greater than the hypotenuse squared, then it is an acute. And if you get the sum of the hypotenuse squared is greater than the sum of the legs, then that is an obtuse triangle. All right, let's apply this with the converse. The converse is just another word for saying it's how to prove that it is a right triangle. It's just showing and plugging in the numbers that a squared plus b squared equals c squared. All right? So it's just proof. So let's do what we did before to see if these are a right triangle or not. So of course you want to label. These are the legs, and this larger number is our hypotenuse. So we want to know if 15 squared plus 36 squared is equal to 4 times the square root of 95. All right, for this one, so would it be A, B, and C? We would see if 8 squared plus 7 squared is equal to the square root of 113. And for this one, our longest side is 13, so this is A and B. We want to see if 12 squared plus 5 squared is equal to 13 squared. All right, so go ahead and take a second now that we've written those. Pause the video and try those and see what you get, and then press play and we'll go over the answers. All right, so 15 squared is 225, and 36 squared is 1296. I hope you have your calculator handy today. And then those added together is 1521. And then 4 times the square root, or 4 root 95, simplifies to 38.987 ... keeps going on and on and on. And then we're going to take the square root of this side, and that gives us 39. And is that equal to 38.987 ... It's very close, but it's not. Even though this rounded would be 39, because they're not exact, this one is not a right triangle. So no, it's not. And since the legs are larger, this would be an acute triangle. All right, let's look at the next one. So this is 64 plus 49, and 64 plus 49 is 113. So the square root of 113 is equal to the square root of 113. Yep. So, I mean, I could get the decimal equivalency. It's like 10.6. 10.6 rounded, but those are equal, so yes, this is a right triangle, because 113, square root of 113 equals square root of 113. All right, last one, 144 plus 25 equals 169. 144 plus 125 is 169, so we already know right there 169 equals 169. If we took the square root, we get 13 equals 13. So yes, these last two are right triangles, and this one is not. It's very close though.